Okay, here we go. We're going to now apply both GCF and DPS rules of factoring. If you look here at my expression, a cubed minus 64a, a lot of you will jump the gun and say, oh, it's got a difference. There's two terms. This must be difference of perfect squares. But it's not. Even though 64 is a perfect square, that exponent's a 3, that exponent's a 1, and they're not even. Therefore, I'm trying to train you to understand every time you're told to factor, you must first look for GCF, what the terms have in common. And these terms do have something in common. They both have an a in common. And we've already discussed this. There's a cubed, there's 3 a's here, there's a to the first, 1 here, a there. How many do they have in common? It's the smaller amount, 1. So I'm going to take out that 1a and tell me what's left. And I need to physically write the division step. So a cubed divided by a would be a squared. Negative 64a divided by a, well, the a's would cancel out and leave us negative 64. We know a divided by a is 1, and 1 times negative 64 would still be negative 64. So we pulled out the GCF. You tell me what's left. Now you look here. If you look, now I do have a difference, and I have perfect squares. 64 is a perfect square. My exponent's even. So this set of parentheses is going to break into 2. A squared is a times a. 64 is 8 times 8. Subtraction means the signs are going to be one of each. Now here's the problem with doing a two-step factoring. A lot of times you guys forget about the GCF. Right now this is not correct. If I multiply this out, a times a would be a squared, and my original expression had an a cubed. So do not forget the GCF. Bring it down. This is your factored form. Now if I check, a times a is a squared, and a squared times another a would be the a cubed. And that's all we need to do, two-step process. Let's try our last expression. 6c to the fourth minus 6. So again, we're going to jump the gun because we're going to see the minus, we're going to see the exponents even, we're going to think it's a difference of perfect squares. Is 6 on the perfect square list? You have to memorize this list. You should be able to say it in your sleep. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and etc. 6 is not on the list. You can't multiply the same number to make 6. So the first rule of factoring is always pull out what's in common. What do these terms have in common? They both can be divided by 6. So I put the 6 in front. I tell me what's left. 6c to the fourth divided by 6 would be c to the fourth. 6 divided by 6 is 1. I do not need to write 1c to the fourth. 6 divided by 6 is 1. There's a negative, so I need to write that one because it's connected by subtraction. Now, I have c to the fourth minus 1. Ooh, there's two terms connected by subtraction. Hey, that's a difference of perfect squares. The exponent's even, 1 is a perfect square. So this parentheses would break into two parentheses. What times itself is c to the fourth? That'd be c squared times c squared. What times itself is 1? That'd be 1 times 1. Subtract means the signs are different. I'm a creature of habit. I put my plus first, my minus second. What did you forget to bring down? That's right, the 6. You pulled the GCF. It's got to come along for the ride. Are we done? No. Oh my, we're still not done factoring. Factoring means to break it down as far as it can go. Okay, can't do anything with 6. That's the GCF. C squared plus 1 doesn't fit this rule. Remember, the rule is difference of perfect squares. A plus is a sum. So we can't do anything with this set of parentheses, so we bring it down. C squared minus 1. There's your difference. And I have an even exponent, and 1 is a perfect square. So this will break down some more. So we're doing the rule difference perfect squares again. We're going to put two parentheses. What times itself is c squared? C times c. What times itself is 1? 1 times 1. Subtract means the signs are opposite. I always put the plus first and then the minus. Now I'm going to look. Am I done? Well, the only thing I'm worried about is this set of parentheses, because I see this, the subtraction, the difference. I see 1, it's a perfect square. But is the letter C a perfect square? No, because that has an odd exponent of 1. There's a 1 there as the exponent, so it's not even. Therefore, I know I'm completely done. You can check it. If you multiply C times C, you get C squared. C squared times C squared would be C to the 4th. C to the 4th times 6 would be 6C to the 4th. Negative 1 times positive 1 is negative 1. Negative 1 times positive 1 is negative 1. Negative 1 times 6, negative 6. So be careful. When we factor, you want to go as far as you can go. All righty, we got one more rule coming up. See you in the next video.